So in this video we are going to give some definitions and some notations. Let us pick elements A, B and C, all elements in a commutative ring. We say that A divides B, or we can also say that A is a divisor of B, or B is a multiple of A. We say that A divides B, and we denote it this way. If there is an element C, if there is one C in the ring, such that B is equal to CA. Okay, so if A divides B, there will be one C here. Okay, so get used to this notation. This is the same as saying that A divides B. Now you can say, well, I know this is all very easy. Yes, but in the context of commutative rings you have to be careful, because for instance, let us say thus 3 divides 2 in the context of the rationals. Well, yes, because there is an element C here in the rationals, right? So C has to be in the rationals. There is an element C, so C is 2/3, right? So C is 2/3. Okay, so 2 is equal to 3 times 3, right? And this element, this will be element C. Okay, so this element is in the rationals. Okay, so yes, it is true that 3 divides 2 in the ring of the rationals. Okay, let us ask the same question. Does 3 divide 2 in the ring of the integers? Well, you're not going to get any C. C will not belong to the rationals, right? So 3 divides 2 in the ring of the rationals, but 3 does not divide 2 in the ring of the integers, because here you cannot find any C in the integers that multiplying by 3 you get 2. Okay, so the only one would be 2/3, but 2 over 3 is not an integer. Okay, another definition. An element U in a commutative ring R is called a unit. This word is very important. If U divides 1 in the commutative ring, that is, if there is a V, an element V in the ring, of course, such that U times V is 1. Okay, so this element here, V will be the inverse of U. Okay, if you have an element U and you multiply by V and you get 1, so V will be the inverse of U. Okay, the usual notation is this one. I don't know if this is I don't want to say this is the usual notation, but this is the notation under multiplication. This is a notation, right? We are used to x times x inverse. Okay, but there are lots of notations for inverse, and this is the usual multiplication inverse. Okay, so sometimes you can also use x prime, lots of notations for this. Okay, so any element such that you pick an element in the ring and you multiply by that one and you get 1. Okay, so this element V will be the inverse, and there are lots of ways to write inverse. Okay, I'll probably be using this one. Of course, units are very important in a ring for many reasons. For instance, let us say we have an element A that is in a ring. Okay, and we know there is a U that is an unit. Okay, so we know that A is the same as, so UV, this is the same as 1, right? Because UV is 1, right? So A is the same as UV times A. And now, using association, you can write it this way. This is very handy. Okay, so you always use this. So this is a very good way to factorize A. Okay, if you need to use factorization. Okay. So here we can also write VA is equal to, we can multiply both by the inverse as, let me write it in a different way. Okay, so A times U, we can write this as VA. I can put U inverse here, U inverse here, so I'll get U inverse times A is the same as VA. Okay, because U is an unit. And here, for an element to be an unit, you also have to look at the ring. Okay, an element can be a unit in one ring and not be in another. Let me give you one example. Let us say element 2 in the ring of the rationals. Okay, this is a unit, right? Because we have element 1/2, right? And 2 times 1/2 is 1. Okay, so you have U, V, and you got 1, right? So this shows that in the ring of the rationals 2 is a unit. Okay, but if you are in the ring of the integers, okay, then you have 2 and you will never get 1V, an element that will give you the identity. Okay, so 2 is a unit in the ring of the rationals, but it is not a unit in the ring of the integers. Well, the fact is that in the ring of the integers, some people say, oh, okay, quickly jump to the conclusion, so that in the ring of the integers there will be no units. Well, wrong. There are 2 units in the ring of the integers. Okay, 1 and -1. So you have infinite units in the ring of the rationals, and you have only 2 units in the ring of the integers.